So for the Kawasaki Ninja 500R, this was the standard head gasket. This is a shim type, 10,000th of an inch or 1/4 millimeter thick. So for my turbo setup, I need to reduce compression to about 8.5 to 1. So I found, I don't know what this gasket's off, I found a composite gasket. This ends up compressing to about 55 thousandths, a little bit over a millimeter and a quarter. But that didn't last. Okay, I ran the boost to 19.5 psi, and this gasket wasn't very happy, so that leaked. So I needed to make a new gasket for it, do something different. So I ended up designing my own based off the two-stroke design. Here's the completed gasket. So this is 50 thousandths thick aluminum. What it is it's a composite gasket of sorts. So it uses O-rings placed in these holes, and then these are all cut out from it. It uses this these seal the water. And then this here, along with a spaghetti cord type, which is set into here, that seals the cam chain oiling. And then the actual compression is an 0.63 thousandths of an inch, 63 thou, by 6 thou thick hypodermic syringe type stainless tubing that I've rolled and then joined. So those sit in here. So that's the actual, as you'd call it, a fire wire for a boosted engine. So that is compressive enough to be able to seal up the top of the head. So I'll go ahead and install that and show you what's going on there. So here's the head gasket in place. Small O-rings all sitting there. So I'll go put the head on the thing now and torque it all down. I'll check between the between the head gasket and the head, make sure there's no actual gap left, like that. I make sure that the stainless tubes compressed fully down to the head gasket thickness. So we'll see how that works. So the cams on the Ninja 500R or the EX 500 are really wild. You can see here duration of 290 degrees and overlap of 85 degrees, the EX 500. So I'm changing that to EN 500 cams, which have a duration of 254 degrees and overlap, very importantly, of 49 degrees. So this much overlap with a turbo engine is a bad idea. This engine would hardly run well. I just couldn't get it to run very well. Anything under 3,000, which is basically when boost started. So anything off boost, the engine would sort of almost run on one cylinder. It was pretty bad. And I messed with the fuel injection timing a lot. I messed with everything, and it basically come down to just the cams. So here's the EX500 cam. Oh, sorry, I got that backwards. You can see the lobe size. Here's the EN500 cam, and here's the EX500 cam. This thing's a lot more duration, a lot wilder. When you can physically see the lobe size, it's a lot. They both have the same lift. I've gone and had to machine this has a cam trigger, so it'll run in sequential injection. So I've gone and machined the cam trigger on this other set of cams. So I'm going to install those and see how that runs. But this should be a big improvement for a boosted engine. I don't believe any Ninja, any like an R1, R6, anything with these wild cams that they basically don't start making power till 7,000 or 8,000 RPM, that you can't use those cams for a boosted engine basically.